Hello again. Now we're going to talk about the law of sines. So far, all the triangles we've been talking about in this trig class have been right triangles. But that is no longer the case. Now we are dealing with oblique triangles. So when we start talking about solving a triangle, we have these different types of triangles. Specifically, we've got 5 types of oblique triangles. And we're going to talk about how we identify them and how we label them, because we have certain triangles we're going to talk about that we can solve with the law of sines. And then we have certain triangles which we can solve using the law of cosines. So let's identify these different types of triangles, how we refer to them, and then we will get into the law of sines specifically. So the first type of triangle we have is AAS, and we read that as angle, angle, side. We can also refer to that as SAA. So AAS, SAA. We're going in order, angle, angle, side. And essentially what that means is we know 2 angles and a side which is not in between those angles. Okay, so here we have angle, side, angle. Here that side is not in between, it's on the outside. So what does that look like in a picture? So we might know, say, an angle and an angle, and then a side that is not between them. So over here we've got a non-included side. Angle, angle, side, side, angle, angle. Either one of those works. So we have 2 angles and then a side which almost appears to be opposite them is known. I'm not going to do this on every single one, but we could say, maybe I knew this angle and this angle and this side. This is another example of angle, angle, side. Okay, so also what we have here, ASA, I'm sure you can guess, that's going to be angle, side, angle. And there's no sense in reversing that. ASA, when I reverse it, it's still ASA. So angle, side, angle. That means we know 2 angles and an included side. So it's included in between. In this situation, we might have angle, side, angle. You see, I go angle to side to angle. It could happen on any side. Here I could have angle, side, angle. All right, so angle, side, angle is a type of triangle. Angle, side, angle. All right, so that's angle, side, angle. Whereas up here, on this one above, let me recolor that. We'll say angle, angle, not included side. So do you see the difference between included, in between, versus not included, not between? So we know 2 angles and a side. It's either going to be angle, angle, side, or angle, side, angle. All right, the third situation, SSA, and we would read that as side, side, angle. And what happens if I reverse SSA? That would be ASS, which is a bad word, right? And that's because this is the pane in the SSA type of triangle, all right? So what does this mean? We know 2 sides and an angle that's not in between them. This is different if we had SAS. You see how A, the angle is between the sides? Here, this is SSA. And SSA, this is the one that's a super pane because there are 8 possible cases. I like to say pain in the SSA. All right. And we'll look at all those 8 cases in a little bit. But right now we're just identifying the types of triangles. So an example of what this looks like, we know 2 sides. So side, another side, and then an angle that is not included. So maybe this angle up here, side, side, angle, or angle, side, side. All right, I could have identified that differently. I could have said side, side, angle over here. So side, side, angle, or angle, side, side. Either of those works. And of course, we can orient and turn this triangle around. However, it would still mean the same thing. So we have side, side, angle. So we're going in a kind of consistent order. All right, so, and like I said, we will talk more about side-side angle triangles, but you can have a situation with 2 solutions, you can have a situation with 1 solution, and you can have a situation with no solutions. We have 2 other types, SAS. SAS is side, angle, side. Side, angle, side. So side, angle, side, that is, we know a side, we have an included angle, and then another side. Side, angle, side. Side, angle, side, side, angle, side. I could draw that, over here. I could say side, angle, side. So that's a different side, angle, side situation. So I'll just look at that and I'll say side, angle, side. And then the last situation you may encounter would be side, 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 which is pretty obvious, where we know all 3 of these sides. So we know a side, and a side. Side, side, side. That one makes pretty good sense to us. So we do want to talk about why not angle, angle, angle. I've come up with all these different combinations. Why are we not including angle, angle, angle? Well, the reason is, and you can see here, these 2 triangles, if I were to lift one up, if I lifted this little triangle, which I do when we're in class, and I drag it over here and I show you that these angles all have the same measure. So just knowing the angles does not tell us anything about the size of the triangle. Angles, only knowing angles, this is only going to tell us about similar. These are called similar triangles. And similar triangles have proportional sides, which means we could look at 2 triangles with the same angles, right? The same 3 angles, and we can clearly see here that they're different side lengths. So it would be hard to nail down exactly, or actually impossible to nail down exactly which triangle we were discussing. Okay, so we have these 5 main types of triangles. Types 1 through 3, these are we're going to talk about using law of sines. And then type 4 and 5, we're going to use law of cosines. So let's talk about what law of sines is. So here we have a triangle. It's an oblique triangle. We do not know if there's specifically any right angle in this triangle. So of course, if we do have a right angle, we revert back to right angle trig with SOHCAHTOA and the Pythagorean theorem, which is kind of shorter in a sense. But here we have a triangle. Given any triangle, remember we label the angles with capital letters and then the sides with lowercase letters. The sides are opposite the corresponding angle. Essentially, what we can do is we can say that A over the sine of A equals b over the sine of b equals c over the sine of c. Now you only need two pairs and you could create a proportion. This is just saying we can create that any way we need to. We could say even that sine of b over b equals sine of f over f. And you're saying, Miss Stein, we don't even have an angle f. Well, we could have a triangle BFK, I don't know. And we just need to match it up. So notice I've flipped these fractions. We can flip, we can write it that way as well. Essentially, all we need to do is to be able to create a proportion using two angles and two sides. So if I was given a triangle with some information, if it is angle, angle, side, angle, or side, side, angle, we can use the law of sines to help us determine the missing sides and angle measures. And so, as I said, we only need, a proportion, which means we need two ratios that we are comparing. So I could say C over the sine of C equals A over the sine of A. That's kind of our setup for using the law of sines. So in this video, we talked about the different types of triangles, and we identified 5 different oblique triangles. And then we said, well, for angle, angle, side, angle, and side, 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 we can use the law of sines to solve a triangle and find any of the missing side lengths and angle measures. So in the next video, we'll do some examples. This is our orientation. These are our notes for law of sines. And then also I want to mention, we will do another video in a little bit, but SSA is a pain in the SSA, right? And so we've got 8 different cases, and essentially what this just means to us is whenever we have an SSA triangle, we have to consider the possibility where we could have a second solution. All right, so I'll conclude this video and then hang tight, stick around. Next up in the playlist, we will do an example solving a law of sines triangle.